Please understand, am I saying that if you do make an XY table for this, that I'll count you wrong? No. If I say graph the equation, you can do it any of those three ways I just said. Now, what do you think I'm going to do, though? I'm going to say there's going to be a problem that says make an XY table. There's going to be a problem that says find the intercepts and then graph. There's going to be a problem that says put in the right form and then tell me the slope and Y-intercept and then graph using it. I'm going to ask you all three ways. But if the problem just says graph this equation, you get to choose. And I'm not going to take points off just because you did it a way that was the hardest way. That's your choice. Right, as long as you get it right, it'll be good. So like we said, this one, the best way to do this one is the fact that the slope is -1/2. And the Y-intercept is what now? 0.03, there it is. So where do I start?
On the y-axis.
I love it. So the Y-intercept is 0.3. And the slope tells me to go. Yeah, I could go down 1, over 2, or I could go up 1, back 2. As long as one of the two is negative, so the negatives don't cancel. Let me stop there. Yes, sir.
Why would it go right instead of going up? So, I mean, you put the last point on negative 2.
So let's look at this. -1/2 officially means fall 1, run 2. So fall 1, run 2. Math says, if you want to be silly and put the negative on the bottom, I don't care. That's what math says. But we say, that actually means something different with slope. That's like me getting back home. So I went there, now I want to get back home. This says go up 1, back 2, right? So I could go up 1, back 2 instead.
So, but you're going towards the negative. That's a positive.
Okay, let's try this again. On this first one, I agree. The 1 is negative, correct?
Yeah.
So I would go down 1. And then I would go run 2, like you said, because now the 2 is positive. Now, if I write it like this, is the 2 positive? If I write it like this, is the 2 positive? Try again. Is that 2 positive?
No, it's negative.
No, there we go. So I would go up 1, back 2. Because it's not positive, it's negative. I want to go in the negative direction. Let me stop there for a second. You guys see that? So math says, I don't give a shit where you put the negative. It's a negative number. I don't care where you put it. Slope says, oh, where you put the negative tells you which way you're going on the line. So it has a visual different meaning. Math is like, whatever. Yes?
Will there ever be a negative on both?
Of course. But then it would be positive. All right. So then the last thing I got to do is draw the line. Yeah, don't stop here. This is bad. So then I draw the line. You can make whatever sound effects you want. All right. So anything else about that problem right there? I mean, that's what I call a bread and butter problem. You got to be able to do this kind of problem. It's just your base foundational problem. Okay.
I have a question on something different. If it's y minus 8 equals 0, there's no x, then there's no x-intercept.
Yes, it's y equals 8. And what kind of a line is y equals 8? Yeah, horizontal.
Yeah, so there's just no x.
Yeah, because a horizontal line, will it ever intersect the x-axis? No, it's parallel to the x-axis. I like it. Okay. So any other questions on this number 13 before we go to 14? My teacher goes too fast. I just ask questions. I'll slow down to me. All right, now, if you guys did this a different way, let's just do this real quick. If I made an XY table, or if I gave you this problem and I said, graph this using an XY table, like, Jeff, I can see the slope, shit. What do you definitely put in for x to start with? 0. You put 0 when you get 3. Negative 1/2 of 0 is 0 plus 3 is 3. Now what's a smart thing to put in here? 2. And what's negative 1/2 times 2? What do the 2's do? They cancel.
It's negative 1.
Negative 1 plus 3, 2. So I'd plot 0, 3, and I would plot 2, 2, and I get the same thing we just got. Of course I would. The method I use should not change the answer I get. I'll give it a move here. All right. What about 14? What's kind of the slightly better way to do 14?
X and Y to 0.
Yeah, finding the intercepts, especially because 3 and 5 both go into 15. So definitely would be good to find the X and Y intercepts. Can you solve for Y? Of course you can. Find the Y-intercept and the slope. The little tears come out like beautiful. It's perfect, right? If we do the intercepts first, X-intercept, how do I find the X-intercept?
Set Y equals 0.
Set Y equals 0. So right there, I already know that this is 0. Because I made it 0. If I set Y equal to 0, I get 3x minus 5 times 0, which is 15. I get 3x equals 15 because, of course, 5 times 0 is 0. Please let that term die. Right? Be compassionate for it. Let it die. It's hurt. And then what do you do to both sides here? Divide by 3. You get x equals 5. Bam! To find the Y-intercept, make x equal to 0. So I already know this. Bam! I'm just looking for this piece. So then I get 3 times 0 minus 5y equals 15. Negative 5y equals 15. So then y equals negative 3. Now real quick, if you think I go too fast on that step, it's because I have to assume now that that is easy. You have to be able to solve equations. Yes?
How do you know by looking at the problem to do that step first?
To do the intercepts?
Yes.
Two things. It's not already solved for y. And 3 and 5 both go into 15. So it's kind of like because I know what I have to do to find intercepts, I'm going to have to divide by those coefficients, and they both go into 15 evenly. So that's a beautiful thing to do. Now, if you didn't see that, you could certainly solve for y. Let's graph this, and then I'll try to solve for y and see what the y-intercept and the slope is. It better be the same answer, or else we can all go home. This math is shit at that point. Let's see what happens. I always get some people like, come on, Jeff, make a mistake, we go. So the x-intercept 5, 0. Y-intercept is 0, negative 3. So there's my line. So what do you get if you solve this for y? What do I have room for this? I'm just going to do this and see if you guys... I could subtract 3x, divide by negative 5. I end up with y equals 3/5 x minus 3. I love it when students are like, how did you get this? Just solve this for y. Again, I have to assume that you know how to do that. This is what you get. What's the y-intercept? 0, negative 3. Bam. And the slope tells me to go up 3 over 5. Same line. Of course, right? The line doesn't give a shit which way I look at it. It's just the line is this line. Okay, I like it. Yes, ma'am.
Like, I still don't understand, like, how do we know not to put it in the y equals mx plus 3?
Oh, no. Again. Okay, let me try this again. We just did. And then I showed you that if you did that, you get the same line. My only point was, it's set up. In fact, I took too long to do that. Hopefully a lot of you guys can do this. If you're finding the intercepts, you go, divide by negative 5, y is negative 3. Bam, divide by 3, x is 5. I mean, do you kind of see what I'm saying? You should have developed some shortcuts with these procedures. You still got to show me a little bit of what's going on. But you can choose any of the three methods. I'm hoping that you realize that the XY table is kind of the slowest method. Right? So hopefully that won't be picked too many times. Yes?
How did the 3 over 5 become, why is it positive? I got it.
Okay, all right. So let me show the steps. Let's see where I got some room. Where's this stuff? So what was the equation?
3x minus 5y.
All right. So you subtract 3x, right?
Yeah.
So what do you have left? Negative 5y. Good so far?
Yeah, then you divide by 5.
Divide by
Negative 5.
negative 5.
Y.
The negatives cancel.
Oh. Alright. Thank you.
Sure. Okay. Is that decent with everybody? You guys understand my message? You didn't mishear what I'm saying? Yes?
So basically, it doesn't matter which method you use to do number 14.
Exactly. I love it. If I just say, now again, trust me, on the test, I'm going to have directions for each method to make sure that you can do each method. But if I have a problem that just says graph this, you could use whichever method you like. Except I got a graphing calculator and we got to copy it. That's not acceptable. Okay. You guys, everybody with me a little bit? Some guys are physically here, but I'm not sure.
Just like working on that.
Oh. Yeah, don't do that right now. Or you can if you want to.
I already did what you're working on.
Okay, fine. All right, guys. What is it about 15? All right. Now, some of the conversations happening right now are mathematically related. That's beautiful. The other ones need to just stop. Right? All right. So what is it about 15 that if you try to force it into a different method is good? This is what I was telling you earlier. When we first learned these, this is a special case. It should be easy. If you try to force it into another method, it could get more difficult. I heard the answer. What kind of line is this? Horizontal. Just think about it. Just think about it. Y has to remain negative 3. If I go up or down, doesn't the y change?
Yes.
But what's the equation say? Y must remain negative 3. So I can only go left and right. So y equals is horizontal. X equals would be vertical. So y equals negative 3 is right here. I'm going to make that.
That's it.
Yeah. Yours doesn't have to be on fire like it was at mine. All right, guys, try out number 16. You can help each other out when we do these things. The one thing you should not be doing is just staring at me right now. You should be doing something. Even if you don't have a blue book, you realize the problem is right there, right? Some of you guys are still just staring at me. Okay, I don't know what to do with you. If you forgot paper, borrow it from somebody. Right now, some of you guys are just staring at the wall. All right, whatever.
My favorite wall, Jeff.
Whatever, yeah, exactly. Pick your favorite wall. But this is not the wall staring time. Under?
Oh, yeah.
Well, plus they'll tell you, they normally tell you like money per hour or...
Yeah, but it doesn't here on the last.
Oh, so it's always the y-axis over the x, always changing y, changing x. Oh, did you?
Yeah, thank you.
Sure.
You got 4x.
So guys, in this problem, why am I using that equation? The other equation is what? What's the other equation? Mx plus b. But what's b? What's b?
0.
No. In general, what is b? The y-intercept. Does this problem tell you the y-intercept? So how can you use an equation that needs the y-intercept if I don't know the y-intercept? So that's why I use this one. It's not a word. It's the fact that the point they gave me is not the y-intercept. I like it. That's why I know to use this equation. You guys done? Oh, come on. I love you guys. Right now, I want you to understand something. Right now, who gives a shit if you get this completely wrong? Right now, right? You want to get it wrong if you have something wrong in your head so that you can correct what's wrong in your head and then not do that mistake later. If you don't even try it, you're not going to be able to really correct what you're looking at wrong. You got to try it. Hopefully you get it right. But it's better to make the mistake and then see why that mistake was a mistake. It's better to do that. Yeah.
So when you're working on this problem and you have it set up in the y minus y1 and 4, is m in this equation going to be negative 4? Or is,
You got to find the slope. Since my line is parallel to that line, what do I have to do first? Find the slope of that other line. Yes. To find the slope of any line equation I'm given, I have to put it into the right form. So the slope of that line is not negative 4. Yeah. No. Okay. All right, guys. So why did I write slope point? Why did I write that? You're some weird math dude, Jeff, and you write weird shit like that. Why? What about this problem told me to write that? Because what does that equation need? The slope and a point. So that I just wrote it to focus myself that I need to find those two things. One of those two things is easy. They told me the point is 1, negative 3. So I had that one from the beginning. The point is 1, negative 3. Check. The other one, my slope, is going to be the same as this guy's slope. But how do I figure out this guy's slope? Solve for y. So his slope is 4, so my slope is 4. If my line would have been perpendicular, my line slope would have been Okay, that line slope is 4. If mine was perpendicular, my slope would have been negative 1/4. I love it. All right. Mine is parallel, so it's the same slope. The mistake you sometimes fall into is you don't do anything to the equation I give you. You've got to put in a y equals mx plus b form to see its slope. And then my slope is the same. Yay, there's not much work to do there. Do I have everything I need for the equation?
Yes.
Yes. So now I just plug in. What am I going to plug in? Y minus what? Negative 3. Because that's the y piece of the point. Equals m 4 times x minus 1, the x piece of the point.
Oh, I get it.
Okay. 1 down, 114 to go.
Oh.
All right. And now the rest of this problem is cleanup. And I know you guys hate it when there's fractions in there. This one, no fractions, but I think you kind of know me by now. I pick up on the fact you hate fractions. I'm going to put fractions in. You just got to go through that slowly. Y plus 3 equals 4x minus 4, so y equals 4x minus 7. Subtract 3 from both sides. Who? 4x minus 7? Okay. So again, there's a problem that says, find the equation of the line that. Don't even read the rest of the shit yet. Write slope, point. And then start reading the rest of it and go, what did they tell me to figure out the slope? Is it perpendicular to something? Did they give me 2 points? And I can do good old y2 minus y1 business, x2 minus x1. And then how do I get the point? Did they tell me a point? Do I have to figure out a point? So I like just trying to get you guys to realize you write those two so you focus on what you need to figure out. Those two things. Once you get those two things figured out, you put them in. You plug them in. The equation exists. We went through the derivation together. It exists now. I just got to find the right stuff and put them in the right place. I like it. Maybe. A little warm in here. A lot of brain heat. All right. Number 17. 17, believe it or not, will be easier because of a key thing. Like whatever you say, man. What is the extra nice thing about this problem? They give you the Y-intercept, so you know the value of B. That was neat. It's like you threw your voice. I like that. Where they tell you? No. Nope. Not for the line they're asking me to find.
Oh, no, that's not. I'm sorry. I'm talking about.
Yeah, that I don't care about.
So if it's perpendicular, then it's like 1/2 left, or negative 1/2, or 2/1.
One of those things. How do you find my slope? Careful then. All right.
Solve for y.
Solve for y.
Subtract 2x.
Yeah, so you get y equals negative 2x plus 7. That's that line. Sometimes I would do this. I would make this 7,097.26. Because who gives a shit about that line's y-intercept? My line is perpendicular, so the only thing about this line I care about is its slope. So who cares if the y-intercept of this is what? I don't care. What's this guy's slope? Negative 2. So what's my slope? Positive 1/2. Kick ass. Which equation can I use?
Y equals 1/2. Oh, I got this.
Right? Because I know the y-intercept. Would it be wrong to use this one? No. This one will still work. It would just be kind of silly. But you could put a 0 there and a 4 there and blah, blah, blah. It'll still work. So here I just get y equals 1/2 x plus 4. Oh, that's so nice, right? When you know the y-intercept, it kicks ass. Yes?
Alright, so I did it the way you were just saying it would work, so like y minus y1 ways that you were just...
Sure?
However, I got y equals negative 2x plus 4. So where did I go wrong?
All right. How do you set it up here? Let's see.
I have y minus 4. Well, my slope, I got a different slope. That's
Oh,
why.
well, that would definitely make everything.
I got negative 2 as my slope.
All right. This line slope is negative 2. My line is perpendicular.
So it's the opposite.
Total opposite. Change the sign and flip it. If you would have done that, it would have worked. Okay. All right. Yes? Yes? Those of you not sleeping with your eyes open or on your phone seem to be doing okay? I like, you guys freak me out when you sleep with your eyes open. Freak me out. Oh, real quick. Now, this kind of graph always is funny to me because imagine going home. Anybody live kind of far away from the school? Anybody?
How far are you talking?
I don't know, 20, 30 miles?
Not live far.
How can he not live far?
No, he doesn't live
Oh,
far. He's like 2 miles.
I used to live next to Balboa Park, and now I live like in La Mesa, so it's, if I forgot something, I'm like, oh yeah, I'm right there, I can just go back. Before it was like, no, screw that, I'm not going back. So we all know if there's a certain kind of time of day, our travel would look more like, well, this, here we go, and oh shit, traffic's not moving. Oh shit, now we're moving. Oh shit, now we're not moving. Oh, there's an accident, I gotta go around it. So it won't really be a straight line. So this is somebody who's traveling at a constant speed. What happened? Something freaky. All right. Constant speed. How do I see that? Because the slope is the same for this whole line, right? Not very physically possible, truly, but oh well, we'll deal with it. Is the person traveling toward or away from home? So this shows the distance in miles the driver is from home. So is the driver going away or towards home? They start off, how far away from home?
250 miles.
350 miles away from home. And what happens to their distance from home? It decreases. So are they going towards home or away from home?
Towards home.
Towards home.
That's what we were
They're getting closer and closer to home.
towards home.
That's what the word towards means. What's the point 1/200 mean?
1 hour.
Yeah, after 1 hour, 200 miles away from home. Right?
So 50 miles now.
I like it. So you're already at this point, most of you should know the slope, for example. Now, part C. Do that one. Aha. Aha. What point on that graph do you know that makes part C much easier? It was the difference between the last two problems we did. One problem we had to use y minus y1 equals m. And the one we just did, we could use y equals mx plus b because we knew the y-intercept. Do we know the y-intercept?
No. Oh, yeah.
Yes.
Sorry.
Yeah. So it should be relatively easy, this problem. What's slope-intercept form mean?
Y minus y.
Y equals mx plus b. M slope, b y-intercept. Slope-intercept, we just decided to just slam those together for the name. Slope-intercept means,
So use y equals mx plus b.
yeah, we totally can because we know the y-intercept. What's the value of b for this problem? What's the value of b? What? Yeah, 250, right? Why? Because that's the y-intercept, right? That's the y piece of the y-intercept. So I know the y-intercept is 0, 250, so I know that b is 250. So what else do I still need to figure out? Slope. And right here, I went down 50 over 1. Or if you want to do between these two, I go down 100 over 2. 100 divided by 2 is 50. So down, though, so it's going to be, yeah, m is negative 50. I go 50 miles closer to home every hour. So y equals negative 50 x
Plus 250.
plus 250, done.
Oh.
When you know the y-intercept, it's going to feel like you left something out because it's going to be so much quicker. When you don't know the y-intercept, you got to do the y minus y1 thing, you got to distribute, get the thing over, get like terms, oh shit, right? It's a little bit more work, but when you know the y-intercept, you plug it in, you're done. That's why it kind of feels like you're cheating somehow. There's got to be more, Jeff. No. And then this last one is just about how far away are we at 2.5 hours?
Like between 100 and 150.
So estimate 125. If you say 120, 130, that's fine. If you say 270, I'm a little worried about you. Should be able to estimate stuff from the graph that it gives you. Okay, I like it. Yes, do you see that? Yes. Yes. It's okay. Y equals mx plus b, m and b. Slope, intercept. Yeah. I like it. The other one, who knows the name of this dude here? Where is that? There.
I thought that was
Point slope. Why do we call it point slope? Because there's a point and slope, right? Again, I'm making fun of us, math people. We went, well, equation's got a point or slope, so we're going to call it point slope. It's crazy. All right. Let's see. Oh, yeah, okay. The rest of this is from like section 3A. Just make sure you guys, obviously, if it's not up in my math lab, you can't do it. But section 3A, there is one more section. We are going to do that after the test. It's going to be on the next test. It's the one dealing with f of x function stuff. We can leave it a little early, it's fine. If anybody still needs a practice test, you probably want to get it. I said, find the intercept and then graph. I think you found it as you were graphing. And you can make sure equation, you gotta find the intercept by itself. I don't know why I did that.
I have two questions. Okay.
Yeah.
One, okay, so the answer will be given on Monday, right?
Yes.
Okay, and then two, how long